Greetings and welcome to October. We are in week 8 and we're working through the week of October 3rd assignments. Just a reminder, you should have your math notebook out and be ready to take good notes. I'm going to go through a lot of practice problems today that will be very helpful for you to have written in your math notebook when you go to do your assignments this week. We've got a warm-up question to get us thinking about what we learned about last week. We learned two postulates that we can use to show that two triangles are congruent. We learned about the side angle side and the side 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 postulate. So taking a look at the triangles below, there are two triangles. Can you prove that those triangles are congruent? And if so, what postulate can you use? So go ahead and click pause and take a moment to think about that and write your answer down in your math notebook. And then when you're ready to check your work with mine, go ahead and click play. So I see that we've got one tick here and one tick here, and that shows me that these two legs are congruent of these two different triangles. Then I see that there's two ticks on this leg and two ticks on this leg. That shows me that those two triangles are congruent. And then last but not least, we've got a leg that is shared by both of our triangles. Therefore, we know that those two legs must be congruent as well. So that leads us to say, yes, we can prove that these two triangles are congruent by using the side, side, side postulate. I'm going to go on to the next slide, so if you need a moment here to take down more notes, remember you can always click pause. All right, so we are going to continue this week to add to the side, 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 and side angle side postulate, and we're going to learn some more postulates that we can use to prove that triangles are congruent. We're going to do that in Unit 2, Session 6. Then we're going to take a look at a fun project, a logo project. So you guys are going to do some research on logos and how brands use logos and what makes a logo pleasing, and then you're going to actually have an opportunity to create your own logo. But since we're learning about triangles, guess what? You're going to have some triangles in your logo and also prove to me that those triangles are congruent. All the directions are in that folder. And then we're going to close out the week with a Unit 2 quiz. Let's move on and learn some of those additional postulates that we can use to show that triangles are congruent. So I had this same slide up last week, so I'm not going to spend a whole lot of time here. Just a reminder that in order for two triangles to be congruent, all the corresponding sides must be congruent and all the corresponding angles must be congruent. So there's really 6 things that need to be true in order for triangles to be congruent. But lucky for us, we've got some postulates that help us kind of take some shortcuts, right, into proving that two triangles are congruent. So last week we learned about the side, side, side postulate and the side angle side. And remember, it's really important that that angle is located between the two sets of corresponding congruent sides. So this week we're going to focus on some additional postulates. So we're going to finish this list here that I put up last week. So this week we're going to learn about the angle side angle, and it works very similar to the side angle side, but now we have two sets of corresponding angles within side, a set of corresponding sides that are sandwiched between our two angles. So just like with the side angle side, the angle had to be included between the two sets of congruent sides. The same is true for the angle side angle. We have two sets of congruent angles with that side sandwiched between or located between those two sets of corresponding angles. Then the next one is angle, angle, side. So if two angles and the non-included side, so see how we've got angle, angle, side, angle, angle, side. If we've got two sets of congruent angles and then a non-included side, then we can use this postulate to prove that two triangles are congruent. And then last but not least, we've got the hypotenuse leg theorem. And we can only use the hypotenuse leg theorem in right triangles only. So this is only in right triangles only, when we've got a right angle in our triangle. We can use the hypotenuse leg. So what that says is if the hypotenuses of two triangles are congruent and a set of legs are congruent, then we can prove the two triangles are congruent. But really what we're using, and we've got the fact that we've got two sets of congruent angles, which are those right angles. So hypotenuse leg only can be used with right triangles. The rest of the time we have to have three things true. So let's move on and learn a little bbit more in detail. Again, angle, side, angle, you have to have that leg, that congruent side, I should say side. The congruent side is sandwiched between the two sets of congruent angles. Angle, side, angle. Angle, angle, side. Angle, angle, side is another postulate that we can use. And order is important. It has to be angle, angle, side. So let's take a look now. Now we've got four. We'll talk about hypotenuse leg in a moment here, but we've got four postulates that we've learned about. We learned the first two last week, the side, 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 angle, side, and this week we're adding to our list with the angle, side, angle, and angle, angle, side. So now we've got four different postulates. And what I want you to do is identify which postulate would prove that the two triangles are congruent. And keep in mind that we might not be able to prove that some of these triangles are congruent. So maybe we can't prove them congruent, and that's okay. So look at number one. We'll call this one number one. Right here. Can we prove these two triangles are congruent? And if so, which postulate can we use? So think about that for a while. And then write down your answer in your math notebook. All right, well, I see that we've got a set of corresponding congruent legs here. And then I see that we've got another set of corresponding legs here. And then located right between these two legs, we've got an angle that is congruent, a set of angles that are congruent. And they're located between the two sets of corresponding sides. So we would use the side angle side in this case. And yes, we can prove that these two triangles are congruent by using the side angle side theorem. What about number two? So look at these two triangles and the information given and tell me if we can conclude that these two triangles are congruent. And if we can, which postulate did you use? So give you a moment to look at those and decide on your own. I'm going to go over the answer now, so if you need more time to try this on your own, go ahead and click pause now. So we've got a tick here and a tick on this leg, so we know that those two legs are congruent. Then we've got one arc here and one arc here, so I know those two angles are congruent. And I've got two little ticks in that arc, so we know that those are congruent as well. So what do we have here? Side, angle, angle, or in opposite order, we've got angle, angle, side, angle, angle, side. Is that one of our postulates? It sure is. We've got the angle, angle, side postulate, and because we can use that, we can prove that these two triangles are in fact congruent by using the angle, angle, side theorem. I'm going to go on to the next slide. Here's another one for you guys to try. So do we have enough information here, and can we use one of our methods that we've learned about, one of our postulates, to prove that these two triangles are congruent, and if so, which postulate can we use? Okay, so go ahead and click pause if you want to try this on your own, otherwise I'm going to go over the answer now. So here we've got a right angle, and we've got a right angle here. So we know that these two angles are congruent. Then we've got one arc here and one arc here, so we know these two angles are congruent. And then we've got a shared leg right here. So we know that those, since that's a shared leg, we know that those two legs are congruent. So we've got angle, angle, side. So yes, we can prove that these two are congruent by using the angle, angle, side theorem. Postulate. I'm going to go on to the next slide. What about, can we first and foremost, can we prove these two triangles are congruent? And if so, which postulate? So go ahead and click pause and try this on your own, because you're going to have to do this week in your graded assignments. So now is a great time to get practice with immediate feedback. So click pause and try these on your own. I see that this leg and this leg are congruent. I see that because there's 2 ticks on this leg and 2 ticks on this leg, those legs are congruent. And then we've got a set of congruent angles. But are they in the correct order of one of our postulates? Does this match up with one of our postulates? So I see that we've got side, side, angle. If we flip that around, that spells that bad word. Remember, that is not a postulate that we can use. That is not one of our postulates. It's not in the correct order. So we cannot prove that these are congruent. We cannot prove that these triangles are congruent. I'm going to go to the next slide. So one more way, and we talked about this briefly, and that's the hypotenuse leg theorem. So remember, we can only use the hypotenuse leg theorem for right triangles. We have to have a right angle. And if we have a right angle in our triangle, as long as we've got a hypotenuse and another set of legs, then we can prove the two triangles are congruent. But we have to have a right angle, and then one of our sets of congruent legs has to be a hypotenuse. So looking at this one, can we use the hypotenuse leg theorem to prove that triangle ABD, so this triangle here, is congruent to ACD triangle? Can we use the hypotenuse leg theorem? Well, first of all, do we have right triangles? And the answer is yes. We've got right angles right here, so they are right triangles. Then we need, in order to use the hypotenuse leg theorem, we need a hypotenuse, congruent hypotenuses. So which leg is our hypotenuse in this triangle? Remember, the hypotenuse is always our longest leg. So this, I'm sorry, not that one. The hypotenuse is this leg right here. This leg right here is our hypotenuse. And it's marked congruent to the hypotenuse of our other leg. And then we would need to prove that just any other set of legs are congruent. Well, this leg right here is being shared by both triangles. So we know that this leg has to be congruent in both triangles. So we do. We've got a hypotenuse and we've got a leg, and it's a right triangle. So yes, we can use the hypotenuse leg theorem in this example. And that's a wrap. So I'm going to throw up the key phrase assignment question. Give me a moment. So one of the postulates we learned about today was a hypotenuse leg postulate, or the HL, the hypotenuse leg, HL. What kind of triangles can you use the hypotenuse leg theorem to prove two triangles are congruent? So we learned that we can only use the hypotenuse leg theorem on a certain type of triangle. What type of triangle can you use that on? And that's it. So if you have any questions or need any help this week, let me know. I'm here to help. Otherwise, have a great rest of your week.